My name is Victor Digoma Ohia, and in our class today, we are going to be looking at some problems I got in the theory of logarithm. Of course, you will realize that before now, we have been able to look at, we are coming from indices, and we'll look at the laws of indices down to exponential functions and indical equations, and then we now connected indices to the theory of logarithm, that's natural logarithm. Okay, so and right now we have started looking at problems that we can use the laws of logarithm to simplify. I have always told us that any problem you see me handle here is most likely Waec examinable problem. So I'm trusting God that as you are going to follow me to look at this problem, you are not going to regret that. All right, let's look at this question. Of course, I got this too from Waec. Okay. This problem says 1/3 log p in base 10 is equals to 1. Find p. As simple as this question might look, one may not, think, out the easy way to handle it. But let's just see what can happen. Solution. All right, now I have this problem. Okay, let me take it from here. I have this problem 1/3 log p in base 10 equals to 1. I'm going to show you a secret I will use here. Of course, you recall the law of logarithm that states that when the logarithm of a number is raised to a given power, it is equal to the product of the logarithm, product of that power and the logarithm of the number. So if you watch here, you realize that I can rewrite this now as log p to power 1/3 in base 10 equals to 1. Now, you also know, or you can check out in our last class when we were introducing the laws of logarithm, we were able to show that the logarithm of a number to its own base is equals to 1. We were able to show that in those explanations. You can check them out. We use the example to also buttress that. So I am going to introduce something here that is similar to the logarithm of a number to this base. So permit me to rewrite this 1 as log 10 in base 10, which we were able to prove that it is 1. Now, can you see something with me as fast as possible that I can show you that you can answer this question in 1 minute if you know this explanation I'm going to give right now? So permit me to take away logarithm in base 10. What do you have left? What you have left is p to power 1/3 equals to 10. Okay, and then what do we have now? Do you realize that this 10 is raised to power 1? Okay, now this p is raised to power 1/3. We are looking for p, and in 1 minute, as we discussed in indices, if you remember where I was trying to clear powers in indices, you remember that when I come to a place like this, what I do is to remove this power, I will find something that I can use to multiply this power so that the power of p here will become 1. Let me take it again. I will look for something that I can use to multiply this power that is existing here so that the power of p will become 1. And by so doing, p is now standing separate. All right, I multiply both powers, multiply powers of both sides. Let me write it. Multiply powers by 3. You realize that this will become p raised to power 1/3 times 3 equals to 10 raised to power 3. Do you realize that here this will become p raised to power 1, which is still p. So I may not even necessarily write 1 equals to 10 raised to power 3. So what is P? P is 1000. P is 1000. This problem, if you look at it, it can be confusing, but I'm telling you that this is something one can just answer in 1 minute, as you can see. All right, the next question says we have log in bracket 4x plus 1 in base 3 minus log in bracket 3x minus 5 in base 3, still in base 3, equals to 2. Now, do you remember when we said that when the logarithm of two numbers are being subtracted, we take the quotient of the numbers to that base. Okay, so that is to say that this thing can be written as log in this base 3. Then I will have 4x plus 1 all over 3x minus 5, then equals to 2. Now, I'm going to still do something. Permit me again to do something here. And you will see that log in base 3 bracket 4x plus 1 over 3x minus 5 is equals to 2 log 3 in base 3. What is log 3 in base 3? It is 1. So this is like saying 2 times 1. It is still 2. I didn't change anything. Now I will apply, I hope you got that. Yeah. So I will apply this now. The product, the power law. Okay. So you still watch me see that log in base 3, then have 4x plus 1 over 3x minus 5 is equals to, this is now log in base log 3 in base 3 raised to power 2. This is raised to power 2 now. Okay, permit me to take away this and this. What do we have? We now have 4x plus 1 over 3x minus 5 equals to 3 raised to power 2, which is 9. Sorry. You can see what happened there now. 3 raised to power 2, which is 9. Okay. Now, at this level, we can cross multiply. We can cross multiply, and we're going to have 9 multiplying this will be 9 in bracket 3x minus 5 equals to this times 1 will be 4x minus 5. So open this bracket, you have 27x. Open this bracket, 9 times 5 is minus 45 equals to 4x minus 5. So in collecting the like terms, I will have 27x minus 4x. I hope we are together. Let this come over here and we will have equals to 45 minus 5. So 27x minus this minus 4x will give us 23x, and 27 minus 4, that should be 23x. 45 minus 45 minus 5 will give us 40. Let me be sure, let me be certain with the operations I have carried out. Let me be very 4x plus 1 times this, cross multiplying. Where did I get this? Oh, no wonder, because I was trying to figure out where this 23x is coming from. Please. We have 4x plus 1 here. 9 times this, we have 9 into 3x minus. It's like I was rushing. Sorry for that. Okay. And then this 4x plus 1 times 1 will give 4x plus 1. Okay. So this will remain 4x plus 1. Because I was wondering how this subtraction here was giving me something I couldn't understand. So, all right. I know you must have observed that, little mistake. So that's why I tell my students, please pay attention whenever I am doing something on the board. You follow me so that if there is any slip in calculation, you can be able to capture it and then point it out to the teacher. All right. So we have here 27x minus 45 goes over here and become 45. In collecting the like terms, 4x come over here minus 4x. So this is 45. Then bring down plus 1. Okay. So this is not 40. This is 46. All right. Good. I think we're having something. Not that, I always approach every mathematical problem with high level of confidence. I don't, there may be a slip while I'm running down the calculation, but I don't approach anything with fear. All right. So divide both sides. Divide both sides by 23. So we have 23x over 23 equals to 46 over 23. So here we have x is equals to, I think, 2, because 23 divided 46 is 2. So we have been able to find the value of x as requested in this question. All right, I am sure that this class will be able to add flavor to what you already know in this, in our discussion in the laws of indices. In the laws of logarithm. Okay, please check out the previous classes we have had already and use it to build up to come to this level. It will help you a lot to know what we are doing here at this level. Please do that. And as you do that, you are not going to regret. Of course, it is going to help you to fortify yourself. In the next class we are going to enter, we are going to be looking at stronger questions as compared to this one we have here. Thank you for being there. Please share this video to your friends out there. Click on the subscription button and on the notification button so that you can be able to be notified when we are making new uploads. And as you subscribe to our channel, you are also encouraging us to grow. Thank you for doing that. God bless you.